Hi, this is Mike from luxblocks.com, and what you're looking at is the beautiful pyramid. So pyramids are basically polyhedron, many-siders, that have triangles. In this case, we'll be using only equilateral triangles, or triangles that have the same length on each side. Triangles on their sides, okay, and a different, perhaps, polygon on their base. Here we have an equilateral triangle with the base too. So this triangle has triangles on all four of its sides. Even the base is a triangle of the same dimensions. So what we have here is a completely symmetrical pyramid, okay, which is also called in Greek a four-sider or a tetrahedron. And carbon molecules and many other molecules and atoms are actually organized in configurations of tetrahedrons. So our DNA, for instance, and the structure of who we are can be derived from the beautiful tetrahedron. Okay, so that's a tetrahedron and it's a pyramid. Okay, the one we're most familiar with is the Egyptian pyramid. Okay, and the Egyptian pyramid and the pyramids in Central and South America are made of a base that has a square, but then it has triangular sides. So that is a square-based pyramid. Okay, if you made its dual on the other side, made a mirror image of it over here, you would have an octahedron, an eight-sided polyhedron called an octahedron. We'll be making those later. But this is half of an octahedron, which would be a symmetrical eight-sided, equilateral, triangle-sided polyhedron. This is a square-based pyramid, like the pyramid at Cheops in Gaza in Egypt or over in Central and South America. This is a classical pyramid we're used to seeing in architecture. And these are also exist very frequently on the tops of roofs of houses, and probably more noticeably like on a church or an older building. Okay, and over here we have another frequency of pyramid, and this is a pentagonal pyramid. And I put these things on the side, these different colored strips of three, so you can see the definition of how it's outlined. And this is a pentagonal pyramid. And again, maybe you can't notice it, but each one of these sides is the same triangle shape as the other ones. Okay, they're all sided with these triangles, but they all kind of blend together here. But if I bend them like this, you can see it more clearly. So that's a triangle, and there's 5 of these on this one. This one bends nicely into this Y shape here, and you can morph it around, and it's a very dynamic, moving kind of shape that you could change into all different kinds of configurations, which is really nice. So this is a pentagonal pyramid, 5 equilateral triangles on its sides, but a pentagonal base, a pentagon or pentagonal base. So those are 3 of the pyramids I want to share with you today. And how you put these together is rather simple. So if we look first at the tetrahedron here, this triangle-based pyramid, you can see that it's made out of these 3 shapes. We could open them up right here. Reason why I didn't show you a hexagonal pyramid is you can see right here when I open this up, and it flattens out. If I put 3 more triangles here, you wouldn't even be able to make a pyramid. It won't stand up because they all will flatten out perfectly flat. So with equilateral triangles, you can't make a pyramid with equilateral triangles. It's a base 6 pyramid. It won't work. It'll be completely flat. But the minute you subtract a pyramid, and I could prove that right now. In fact, I'll prove it to you because that sounds like made up. Like, why can't I do that? So instead of just saying that's true, I will take these right here. I'll make one out of that square pyramid I had. I just destroyed my square pyramid for you because it's worth it. So I have these 2 pyramids, these two sections that are both, if I fold them up, they're both tetrahedrons. They're both 3 sides at the top with a base, okay? Aren't those nice? Look at that. Unless I want to marry them together, make a bigger pyramid now. Not a 5, but a 6 pyramid. So I'll open this up, and its 3 sides will be shared. With these sides over here, we're going to share them. But as they come together, okay, and I share them, they're going to get flatter and flatter until they fit perfectly together. And when we snap these together perfectly, just like this, snap. Hey, it doesn't want to come up. It's just pretty flat, right? Its cousin over here, the 5er, beautiful pentagonal pyramid, look at that. But this guy is just flat because the angles all equal up to 360 degrees and make a nice, beautiful flat. But when we substitute, let's do a little subtraction. Let's substitute out this guy. Let's take him away. So I'll take out this triangle here. I'll substitute it out. I'll take it out. Literally ripping it out. So now that I ripped it out, this is the same amount of triangles as this one. Let's see when I make this pie go together here. Well, watch what happens. It'll kind of want to, if we let it here, yeah, it'll want to rise up. You see how it just rose up? it'll flatten out again. It'll rise up and round out and develop a form off the tabletop and flatten out again. So this is a hexagon minus one triangle, okay? Or a triangle plus one pentagon will make this flat hexagonal shape, but it's not a pyramid anymore. So if I button these up, or zip them up, however you want to say it, with Lux, it's a snap, but it's kind of like you're zipping up things too, right? Look at that, boom, it's the same as this one. Isn't that beautiful? So that's how they're related. That's how things like bubbles form so easily. You get a film of soap on water, right? And air will come up through that film and it'll just start to substitute sides, and the film will turn from a flat film on the water into a bubble, okay? It starts to round out. It starts to round out into a sphere. Okay, spheres are usually divided by these pentagons and triangles into round shapes, which we will talk about very soon. It's Mike from Lux talking to you about pyramids. See you next time.